Hi, I want to talk about an example of drawing free body diagrams, and the example that I want to use is a jet aircraft that's accelerating down a runway in order to reach its takeoff velocity, but it is already moving at a relatively fast speed, but less than the takeoff velocity that's needed. Now, in our physical situation, we always draw a picture, and it's good to try to think about and identify what forces might be acting on that object. Some of those forces are going to be contact forces. Some of those forces could be forces that act at a distance, like gravity or electromagnetic forces. And if there's an acceleration, and our acceleration's forward, we should have a force picture that shows us with a net force forward. Now, for a plane, if it's a jet plane, then that engine on the back is creating a force of thrust. So for my forces, I'm just going to use F with the subscript for each force. And because we're talking about a situation of a plane, or on Earth, any object near a large planet has a weight, the force of gravity acting on that object. Now, if the plane hasn't yet taken off, the wheels are going to be in contact with the ground. So if there's a wheel in contact with the ground, then that force of touch is a normal force between the wheel and the ground. And even if the wheels are rolling, there still is going to be some friction associated with the motion. And for rolling motion, most of the rolling friction is because of the deforming of the wheel as it's rolling and continuously changing shape, but we'll just identify that there has to be some friction F. And if we're moving through air at a high speed, well, we're going to deal with air resistance. So F sub D for a drag force, another name for air resistance. And planes fly because of lift. So that means there would have to be some sort of force of lift, which we'll talk about as we get into chapter 14, talking about fluids and Bernoulli's principle. So, we've identified all of the forces that might be there. Now we need to identify how they're going to be acting on our object of interest, our plane. So I always like to draw a box right around my object. And then some forces are just going to act from far away. And I'm going to take those forces and show them just on my object itself. And the only force at a distance we're really dealing with here is the force of weight. So the force of weight is Earth pulling down on that plane, and we never really think about the plane pulling up on Earth because planes are a lot smaller than the planet we live on. Now, for the contact forces, I like to draw those forces along the boundary of this plane where they're acting. And I'm actually going to tighten up my boundary just a little bit and make it right around the surface of this plane, since I have this physical object here. So for the thrust is between the rocket motor and the stuff that's getting flung out the back of the rocket motor. So if the stuff in the back is getting pushed to the left, then there's a force of thrust that's going to be pushing that plane forward. And for air resistance, the plane is running into the air, so there'll be that force of drag pushing the plane backwards. Now, where the wheels make contact, there would be normal force for each wheel that's in contact, and along those wheels, because of that deformation, or possibly any skidding or sliding going on inside bearings, there would be a force of friction. And that force of friction inside would be opposing the motion that we have of our object. And the final force that we would get would be lift, so that force of lift would be pushing upward all along the wings of our plane. So, if we want to draw a free body diagram, we're assuming that all objects for now are particles. So there's my particle, there's my plane. It could be a pilot, it could be a cow, it could be anything we want it to be, but since everything's a particle, we're just going to draw that little tiny point. Now, I'm going to take my forces and from that point, draw them as they're acting on my plane. And I want to try to draw them with a sense of proportion for how large they'd be. So my weight is acting straight down. My normal force, I'm not going to draw the fact that they're two, because there are two wheels here in my picture. I'm just going to assume that there's some normal force that's up. The other force that's up is lift. So I have my force of lift, and I tried to draw this so that those two forces summed together equals the size of my force of gravity, because if my acceleration's forward, only my acceleration is an up. So that means that my net force here has to be 0, my total of my vectors has to have the same length. Now to have a forward acceleration, my forward force needs to be larger than any backward forces. So my forward force, the thrust from the engines, is acting to the right, and then I would have any friction and any air resistance acting towards the back. So here, this force is larger than those two, so this isn't technically part of a free body diagram, but I always like to just draw in a reminder that if something's accelerating, I'll just note an acceleration and draw the direction of the acceleration. But if I know that something's in equilibrium, where the acceleration's 0, then I will write A equals 0 in my picture and make sure that all of my forces look like they line up in size, canceling everything out and not changing whatever velocity that object would have. So for this plane, once it gets off the ground and is flying at a constant cruising altitude, the thrust would be pushing forward as the drag force is pushing backwards, with those two forces balanced. There'd be no normal force off the ground, but the lift upward would be balancing the weight of the plane downward. Thanks for watching.